the math physics of computation, then you need to know some computation. Right? So, I can imagine a mixed audience. Anyway, so what we have now, it's sort of ironic to some extent. Now, I assume this Sipser is a computer science guy, obviously with a math tendency. So what he's done now, he's brought in a conventional computing concept of a procedure. What's a procedure? So for those of you who don't have a computer science background, what is a procedure? Well, it's sort of like a recipe. A recipe for cooking is just a list of steps you have to do to cook something. So a procedure is a list of steps you have to go through. First you do this, then you do that, so on and so on and so on, to solve some problem, to do something, to achieve some goal, to reach a goal. So a procedure is just a list of necessary steps. Okay. Now, so this procedure, it has a label. You can guess what it's going to do. So the label of the name, if you like, of this procedure is just convert. And this procedure, it takes as input G, so big G. So you can guess what this procedure is doing. So it will take a GNFA, a formal description of a GNFA, and as output, it will it will deliver the equivalent regular expression. Okay? So in a sense you could look on convert as a kind of function, and that's your input, and as output would be the regular expression. Okay? So the proof will use this procedure, even though, so it's a kind of computer science based pure math, if you like. It's usually the other way, but it's interesting to go this way from conventional computer science, talking about procedures which are very common in computer programming. Those with a computer science background will, this will be very familiar to those with no background in computer science. Just think of this as a function, right? And it operates on this this G, which is a formal description of a generalized, the GNFA. Okay, and the output of your function will be the corresponding regular expression R. Okay. So how does this work? Look on it as a function, if you like, or if you're a computer science guy, a procedure. How does this work? Well, again, a notion of from computer science comes in, called recursion. Now, again, if you're a computer science person, you'll be familiar with that concept. If you're not, I need to explain a bit what recursion is. In ordinary English, to recur just means to happen again. Okay? Now, in computer science, recursion is now this procedure. Just think of it as a list of steps, okay, to achieve some goal. Now, in recursion, a recursive, that's the adjective, a recursive program. Amongst those steps, there will be the use. One of those steps will be to use the same program. The same function, if you like, or procedure, convert. So imagine here is your list of steps, your recipe, if you like, your algorithm. They're all the same concept. So an algorithm is just a recipe. This is just the computer science word for recipe, step by step. So here's your list of steps, okay, and that's your algorithm or your procedure. Now, one of those steps might be to use the same algorithm again. So within the algorithm is a call. What does that mean? You're asked to execute a step which is the algorithm again. So you have the same algorithm within the algorithm. You have the same procedure within the procedure. That is recursion, because it's happened again. You're seeing it again. Now you may scratch, and if you're not a computer science person, you may scratch your head and say, well, that sounds like an infinite loop. Right? If it's calling itself, which calls itself, which calls itself, how do you stop? And that's a good question. Now, the way that you do stop is each time you make that call, in other words, each time you use the procedure within the procedure, like you use the recipe within the recipe, each time you do that, the G that gets passed, that gets used in using this conversion, this function, the G here, it's a smaller G. The GNFA has one less state. Okay, and that's the critical point. That's the way you stop an infinite looping, infinite regress. So now, okay, here's your first recipe, your first procedure, your first algorithm, and in it is a call, asking you to use the recipe again. Okay, so you loop out of to execute convert. So here's your list of things, and here is convert, and so you loop back to convert again, and then you come to this convert again and loop back and again. Now each time you're looping back, the size of your G that you're using in your convert task, that will go down by 1 each time, until eventually the size of your G is just 2. They're just 2 states in your GNFA, and when that happens, you don't recurse anymore. You don't loop back anymore. You just calculate the answer and output the answer, and you can get things from there. Now I don't want to go into a whole lecture on what recursion is. This is not a lecture on techniques of computer programming. But anyway, so you keep calling convert until eventually your G has only 2 states, and then your convert program is able to actually calculate what the answer is to this. It outputs the actual answer, and it does that by looking at the label of the transition arrow between the start state and the accept state. Okay, so it outputs the result that you're looking for, and you've done that by using convert multiple times, and each time you use it, the size of G, like the number of states in other words, goes down by 1. Okay, so you avoid this infinite loop, right, by calling or using this procedure or recipe or algorithm, right? Each time you use it, the size of G, number of states, goes down by 1, as I said several times. Okay. All right. Now, running out of board session, but so what happens now is a description of how convert works, more in detail. So this will be almost like pseudo code, like a guide, almost like commentary if you're writing actual code in a computer program. This sort of description here would be like a description of the actual code. So when you read like the commentary of the code. Okay, so what is this procedure or recipe or algorithm doing? Okay, so it takes input G, which is just a GNFA, and the first step, it's assuming that K, that's the number of states in this GNFA. Alright? Well, yeah, probably I'll stop there because we barely started. Now the first thing you'll do is you'll check is K equal to 2, because if it is, then immediately output the answer. If it's greater than 2, then, well, I'll leave off there, and if it's greater than 2, that's where we will continue on the next session.